Hello viewers, welcome to Usman Chayin Physics Maths class. In our tutorial today, I shall continue with the discussion on half-life. In my previous video, I have talked on or I have proved the equation of half-life, and in today's video, we would like to look at the relationship between decay constant and half-life. But before we get into decay constant and half-life, it's very important for us to revisit the equation. In my last video, I said that the equation is end equal n naught e raised to power negative lambda t. This was the equation we have proved in my last video. Now the relationship between the end and this t, if you plot the graph of end and t, you are going to obtain a certain parabola line, okay? And that parabola line, we call it a decay curve and time. So this is what exactly you're going to obtain. So this is the graph of end against time t, against the time, okay? So if you plot this graph, this is what you're going to obtain, okay? So at this point, we have end node where the line touches the vertical line, okay, or y-axis. We have end node. Now after some time, we're going to have end node over 2. After some time, we can have end node over 4. All right. So at end node over 2, the time will be, this is going to be time, which is t, which is the half life. At this very point, we have another half life, that is t again. All right. So as if somebody is asking us, at n over 2 we have half life, at n over 4 we have 2 of the half life continuously, okay? So I said this curve, we call it what? A decay curve and time, a decay curve and time. This is called a decay curve and time. Now we have looked at the graph of end and t. Now this is what we call the constant, and this constant is called decay constant. It's called decay constant, represented by this. Decay constant. What is then the decay constant? We can define decay constant as the instantaneous rate of decay per unit atom of a substance. That is what decay constant is, okay? So this is what decay constant is. A decay constant, which is represented by lambda, is the instantaneous rate of decay per unit atom of a substance. That is decay constant. Now at half-life, at half-life, which is t over 2, then end will be n naught over 2 at half-life. Now if we substitute this into this very equation again, we take this into the equation where our end, instead of writing n, now we write n naught over 2 equal to n naught e raised to power negative lambda. Instead of writing t, we now write half-life because it's at half-life now. So we have t half, okay? So from here, this can also be written as 1 over 2, then multiplied by n naught equal n naught e minus lambda t half, Okay, so this will cancel this. So we are having 1 over 2 is equal E minus lambda half life. All right, so if you want to remove this negative sign, you take the reciprocal of this. A reciprocal of this is going to give us 2 equal to E. Instead of writing negative, there will be no longer negative there, so we have lambda half life. Okay, so from here, if you want to remove the natural log, you take ln. So this will become ln 2 equal lambda half life. You see the natural log have gone if you have this. All right, so from here ln 2 is equal to 0.693 equal lambda half life. So from that very point, we come over to this side, we divide through by lambda so that our half life should be equal to 0.693 all over lambda, which is the k constant. Or we can divide through by half life so that we have lambda will be equal to 0.693 all over half life. So these are the relationship between the k constant lambda and the half-life. We can use this in solving the half-life, different type of question. But in case if you are taking a CBT exam, this method will be using this formula will be a bit tedious for you. So we have to fall back to ZIPO method or other method, which are a bit simpler compared to this. So in my next video, I'll be talking on the example using both the method. We use this method, and of course we use the other method and see which of them is more simpler and faster. Okay, so in case if this is your first time watching this very video, I encourage you to go to YouTube and subscribe to Usman Chayin Physics Maths class. Follow Usman Chayin Physics Maths class on Facebook and on